today, we're fortunate to have a few minutes with Mike Vasquez, who is the co-founder and CEO of a Chicago-based consulting firm, 3 Degrees. Mike, good to see you.
Hello, nice to see you as well.
Well, today, the goal of this conversation is just to allow our 3D Hills 2020 audience to get to know you a little bit better before the event in June. So I'd like to start with, why don't you tell us a little bit about 3 Degrees?
Sure. So thanks for having me. So 3 Degrees is a company I started in 2012, so going on a number of years, as a researcher, Ph.D. coming out of the material science department, focused on additive manufacturing. I was really interested in how companies and organizations were thinking about deploying the technology in a large array of industries, and was finding that there was kind of this, I'd call it a dirt road. There wasn't really a super highway or even a paved road to that fact, in terms of helping people kind of move from, hey, 3D printing is an interesting technology, to, okay, now we're ready to deploy it, ready to bring it mainstream. So the idea of 3 Degrees was an organization to help companies kind of navigate the process of thinking about how 3D printing could impact their business, whether that be in an end user capacity, so helping identify applications or set up a facility. We do also a lot of work with chemical companies who are in the same boat, to think like, okay, if 3D printing kind of takes off in 1 or 2 areas, how does that impact us as a material supplier in injection molding or kind of metals or whatever it may be. So we thought that we could help kind of be a neutral kind of technical expert on the technology, and it's been a great ride. I've learned a lot, just starting it from scratch with zero in the bank account, and then kind of building it, going on 8 years now. And so we've, over that time, we've worked with almost 50 different companies, range of large and small companies. We've got a small team here, and we've been have generated some software as well. So seen a lot, and excited to continue to be part of the 3D printing ecosystem.
Yeah, I think what's impressive, and I think we should trace the story a little bit further earlier in your life. What's impressive is you started this company right out of academia. So you finished your PhD in material science in England, right? Is that correct?
That's right. Yep.
The Loughborough University. I'm sorry, my pronunciation is terrible.
Loughborough University. So my dad still can't say it even after a decade now.
But before that, you were also at MIT, which has been the mothership of a lot of 3D printing related innovations. But what inspired you to even be on this journey? First material science, and then 3D printing.
Yeah, so kind of the material science part, that's easy. So I really was into sports growing up. I played baseball all the way kind of through high school and into college. I continued to play today. And kind of early on, there was I observed that every year, kind of being in Little League and in high school, they would come out with a new bat, one material. So 1 year it was aluminum, and then the next year it was graphite, the next year it was carbon fiber. And I'm like, like somewhere in some office, like it's some person's job to make decisions about what goes into a baseball bat. And I think that's awesome. And so one of the first classes I took at MIT, where I was undergrad, was a material science course, and kind of talked about some of the different kind of underlying materials and chemistry, and really fell in love with that, and ended up doing my first internship at Easton Sports, which makes metal and carbon fiber baseball bats. So it kind of came full circle. And then from there, kind of quickly realized that sports was a really interesting industry, in the sense that, similar to aerospace, where they're really testing new materials, like faster, higher, kind of whatever it may be in terms of performance. But one of the things they didn't have was the regulations. So you don't have to go through FAA testing to to make a shoe or make a baseball bat. You can really try what's out there. And so from a technology perspective, they're really on the cutting edge of any major technology trend, whether it's lightweighting with aluminum honeycomb or carbon fiber or these composites. And the same was true with 3D printing. And so while I was at MIT, worked in the Sports Innovation Lab, started to do some collaborative projects with Loughborough University in the UK, which was really big into both 3D printing. They were probably one of the first in the world to have a degree program in the space, and the high-speed sintering technology came out of there. It's now the HP technology. And so they were working on all sorts of 3D printing related endeavors and research, but also they're kind of the hub in the UK and maybe if not Europe itself on sports and sports research. And it was just kind of a coincidence that they matched, and I ended up doing a project on applying kind of and developing new materials for snowboarding applications with Burton snowboards.
I was going to say that. That's my interest.
Yeah, and
ski equipment and snowboarding, snowboards. Yeah.
Yeah, it was great. I mean, I didn't know I had skied before starting this, so I'd spent kind of during the PhD, I would spend part time in the UK doing research and DSEs, all the things that you would do as a typical academic in the material science department. But in the winter times, I would be doing hands-on research at Burton up in Burlington, Vermont, and I had never. I'd skied, but I'm from Minnesota, so I'd been on the snow and comfortable with that, but I'd never snowboarded before. And so the guys I was working with, very special guys, Ryan Larson and John Cross, they took me out to the slopes and gave me a board, gave me a helmet, and said, there's only one. It was like the first snow of the year. And they said, we're going to do a bunch of runs. We'll see you as you make your way down the hill. I'm like, yeah, like I'll try it. Like I'm relatively like I like to work out. I'm in good shape. It shouldn't take long. And I think they did 4 or 5 runs in 2 hours, or like we ended up being out there for about 2 hours before work, and they'd gone down 4 or 5 times, even taking a break. And I finally made it down at the very end, just up and down, up and down, but got the hang of it quickly. And we ended up doing a lot of good work in terms of developing some new polymer types and elastomerics for some applications they were doing in the binding space and padding.
That's very cool. I mean, I'm not a super sports fan, unfortunately, but I know a large audience out there loves sports. And what you just said, it really opened up a lot of interesting conversation in the future, innovations in sports and et cetera. But I think, I would say it's fair to say that no one is in love with a molecule or polymer, but what we're really in love with is the potential of the applications, the end applications. So, our conference upcoming, and in general, the 3D Hills community in general, we're focusing on healthcare applications. And you have worked on a couple of projects in the past. You want to share some of that with us?
Sure. Kind of in a similar context, I think what we try to think about in terms of how do you apply 3D printing and whether it be sports or aerospace or especially medical is you really have to understand the full process, especially if it's going into a person's body, certainly, or if it's a support mechanism or an implant or whatever it may be, a prosthetic. And so what we've really focused on is understanding the entire process. And most recently, a project we worked on was looking at the development of call it an infant helmet. So I've got 2 kids, 1 and 3, so very, very small kids. And kind of one of the interesting things now in terms big thing is sleep. And the guidance from doctors around the world is to make sure that infants sleep on their back to help with breathing and things like that when they're little, especially, and that can lead to unintended consequences of what's called flat head syndrome, where kind of you see it on some littler kids. And there are some different approaches to treating that, and one of which is having kids wear a helmet to help either protect them while they're sleeping, so it doesn't flatten as much, or help kind of correct some of the shifts that have happened. It's not necessarily a lifelike damaging issue, but more kind of it's just helpful for that time period. And one of the challenges that actually a family friend of ours, they live down the street, kids about our age, they were saying just in passing one day that, yeah, our kid has to get this, but like insurance isn't covering it, or only partially covering it, and it costs about $5,000-$6,000 for one of these things. And if you look at it, it's a piece of molded plastic. It's not very big because they're small, they're kids, and it's got some Velcro on it, and looks entirely uncomfortable. I wouldn't want to wear it for any particular time, and the kids have to wear it for a long time.
Yeah, that sounds medieval.
Yeah, and so we started just kind of brainstorming, like, hey, like this seems like something where 3D printing could make an impact, and worked with Northern Illinois University to put some approaches together of both lightweighting the helmet itself, coming up with a process from start to finish to say, okay, let's take some of the scan data or the data we get from measurements and build a process that we can maybe explore whether this is something that could be not optimized, but just improved, or just a kind of a feasibility study, and actually came up with some pretty interesting ideas, both in terms of cost. I mean, you can make these for certainly much cheaper with various printing technologies on the polymer side, but also you can make improvements. You can have it grow along with the child, so making some adjustments with dials. We added in some breathable areas, and cleaning was another big issue, right? Like kids like to put their hands in there. Like my daughter puts her hands in her hair all the time while she's eating, so they get messy. And so for $5,000, you could have 2 or 3, if not more. So you could clean one and things. So, so we did that as kind of both a design exercise, but also leverage some of the software tools we've developed to help with tracking the process inputs, which is also very important. So the materials inputs or process details, your inspection, post-processing, so that you had a qualified process at the end to make sure that even in this context, you build something that's robust and repeatable.
Mm-hmm. Yeah, so based on your written interview, it sounds like a large component of your work focused on how to move 3D printing into the production space. Is this helmet, first of all, in production, or there's a potential for it to be in a larger scale production?
Yeah, certainly kind of early days in terms of getting out to production. We're talking with a few kind of medical professionals, doctors and things to move it along and continue to work with the university. So it's still probably early days, but we've made some really nice prototypes, and I think
Yeah, and I have to say, I mean, in your written interview, I can already tell just a slight sense of frustration of that it is not very easy to move these, good designs, potentially good designs, into production. So what do you think is the biggest challenge right now for moving 3D printing into production?
Yeah, I mean, I think there is a disconnect between kind of the way people perceive 3D printing. So a lot of people's first impression of 3D printing often comes from a filament-based technology, a MakerBot, something fairly simple, and not to say they're simple machines, but like it's very understandable, right? Like it's like decorating a cake almost. Yeah. But when you get into kind of the production technology, there's just a lot more variables that need to be understood. Certainly from the material science standpoint, you're kind of building the material as you go on the powder side. So you're kind of melting and reheating and cooling materials. And so the biggest disconnect, I would say, is like the understanding of kind of all the pieces that go into a finished part. And so not just the raw materials, but your design, your process, the machine itself. There could be hundreds of variables in there that you don't even know about from that perspective, and one machine may not be identical to the other, and build orientation makes a difference. And then what you have to do after the fact is there post-processing. How do you inspect it? When do you expect it? Like how do I test a 3D printed part to say that it's going to last 10 years down the road, right? Like most 3D printers haven't been around that long. So how do you think about that in terms of a problem, whether is it going to be in a body? Is it going to be exposed to different solvents for cleaning and things like that? So there's a lot of, I think, details that say, okay, I can print the design. Like that's not like, that's the easy part. Like, I can mostly print like some sort of design, but is the intent there? Or is the rigor there to say that, okay, the materials match with the application, match with long-term sustainability or ability to perform its role. So I'd say that's kind of putting that all together is
By the way, I love the fact that you brought up the word sustainability, because a lot of other people don't think about that element, and you're absolutely right. There are hundreds of elements that need to be considered, and I think that disconnect is both on an individual level and also on an organizational level. Mm-hmm. So now, to tackle that problem, you guys invested to create a new software called Trace. How is that different from the other workflow software that we have on the market?
Yeah, so this came out of personal frustration more than anything. We were working with a number of companies, kind of helping them put the production facility together. And I like how you mentioned the disconnect between the people, well, just in organizations. So oftentimes there's a big disconnect between the people that spend the money to buy a printer and the people that are operating it. In just terms of how easy something is to make, right? Like most people just see the finished part, but you don't understand what it took to get there. And so what we were realizing pretty quickly is for those organizations that were making significant investments into the machines to make parts, some of the back end, I would say the plumbing was somewhat disconnected, even in the sense of, or especially in the sense of just categorizing, okay, where's your material stockpile? Like where's your standards and your safety protocols for your operators? And all this was on these different islands, we called it. Like a lot of it relied on some kind of engineer, technicians, Excel spreadsheet that they have, and some of it's an email, and some of it's a Dropbox or SharePoint, and it was all over the place. I mean, it existed, like it was there, like you could get machine data and all that stuff, but it wasn't very well compiled, and especially in the context of the 3D printing workflow. And so ended up interviewing about 50 different people that worked in the space, operators from engineers to management to people that make standards for 3D printing, and just try to get an understanding of like, hey, what's best practice here? And most people hadn't thought about it. It was like, hey, we use Excel. Like I'd say, like that's the biggest, by far the biggest solution right now. It's 95% of what people are doing. And just thought that there could be a more streamlined solution. And so kind of our approach with Trace, the software we developed, is really a kind of management tool for a lot of your technical details within the workflow process. So managing your material blends and managing process data, like how is your machine interacting with your material, process details that we can feed in, and inspection, and all of that in one place, along with your safety standards and how you're recycling it or how you're disposing your materials. And so kind of the approach we're taking is more of a technical resource for kind of managing that 3D printing data, for whether you're developing materials or going through that iterative process of saying, hey, we need to find our workflow that works for us. Like we need to spec our materials. We need to kind of go through the process of finding our parameters. So kind of people in that range up to the people that are going for the qualification of their process through FAA or FDA approaches. So making sure you have that data and it's correlated back to actual standards, which is another big thing that we tried to incorporate. Is there's a lot of good information out there from the likes of ASTM and ISO and the American Welding Society that put down a lot of this information in one format or another. We tried to compile it a little bit so that there's
I think the issue is no one was compiling it. That's the issue. So is this offered as part of your consulting service, or this is a standalone software that people can purchase and use?
It's both. We're as a small company. Okay. We're starting as what we found is that certainly you can purchase a standalone loan tool, but what has often been helpful with folks is we help give people a walkthrough of what does their process look like or what should it look like. Because we've worked with so many different companies and gone through the process, a lot of times we offer a lot of just kind of different perspectives that they may not have. Like, hey, you thought about this, or like why, like maybe you should be looking at documenting it in this way or looking at this standard. So typically we kind of help them get it stood up and as well as just having the software. Because I think our standpoint is, I mean, there's with any tool, right? Like there's no shortage of data that we can measure. I mean, that's not the commodity. Is how do you use it in a way that you can test hypotheses and say, okay, our mechanical properties all of a sudden drop down. Like, let's test some hypotheses. Was it a batch change, or was it a material, or was it a machine issue that we needed a maintenance issue or something? So I think what we try to do is help empower people to test some of those hypotheses in an easier way, like than they would have before, with looking through their email or checking Excel or something like that. How
to use the data they collect. That's the key, you're saying.
Exactly. Yeah.
Okay. Well, thank you very much, Mike, for this very insightful interview. I'm very much looking forward to your presentation at 3D Heals 2020. We're going to have a very exciting panel on material science from many different angles, and I'm also very excited to see the conversations among the speakers and also speaker and audience interaction. So thank you very much for today's time.
Thank you.
And I'll see you soon.